If you want to understand the most dangerous boiler emergency and how to respond to it properly, then this video is for you. Hello and welcome. It's a pleasure to have you back with Divi's instructional video series on how to handle common steam boiler operating faults. Today's topic, boiler dryout emergency, severe low water condition. What is a boiler dryout condition? As you may already know, boiler water levels are categorized into 4 basic stages. Level 1, full water level, feed water pump stops. Level 2, low water level, feed water pump starts. Level 3, low water alarm, warning level 1. Visual and audible alarms are triggered. Boiler continues running in automatic mode. Level 4, critical low water alarm, warning level 2. Emergency alarms activate. Boiler locks out automatic mode and can only be operated manually or with a supervisor's password. A boiler dryout occurs when the water level falls below level 4, indicating an extreme loss of water. This is the most critical and hazardous situation in boiler operation. The heat transfer tubes are no longer submerged in water and continue to receive heat input, leading to overheating and possible rupture. If your factory relies on steam boilers, take a few minutes to fully understand the causes, consequences, and emergency procedures. Remember, a boiler operating without water doesn't just destroy equipment, it can endanger lives. Part 1, root causes of a boiler dryout condition. Here are the 5 most common causes of severe low water level. Operator negligence, infrequent or improper monitoring of the water level indicator, sight glass, misreading water level due to poor visibility or lighting, malfunction of water level control systems, faulty level sensors, failed alarm systems, malfunctioning modulating control valves, leaking or jammed check valves causing unnoticed water loss, possibly due to operator absence or falling asleep during the shift. Feed water pump or piping failure, feed water pump, motor failure, blockage in feed lines, or heavy scaling in economizer. Entirely dependent on auto mode without manual checks. Example, leaks in economizer tubes can prevent feed water from entering the boiler. Poor feed water quality, high total dissolved solids, TDS, or suspended solids leading to scale deposits and blockages. Sudden spike in steam demand. Increased steam consumption without sufficient feed water compensation causes rapid level drop. There are other possible reasons, but these are the most prevalent. Part 2, consequences of boiler dryout. Why it's so dangerous. Operating a boiler under dry conditions can result in catastrophic failures, sudden pressure escalation. Without water to absorb heat, metal surfaces overheat. Introducing cold water suddenly can trigger a boiler explosion due to thermal shock. Severe equipment damage. Superheater tubes, water wall tubes, and furnace walls may warp, crack, or rupture due to overheating. Operational downtime. Complete boiler shutdown may halt the entire production line, leading to significant economic losses. To avoid these consequences, let's proceed to the emergency response steps. Part 3, emergency response. What to do when a boiler runs dry. This is the most critical part of this video. Correct actions can eliminate danger, protect equipment, and minimize unnecessary or avoidable damage. If a dryout is detected, stay calm, do not panic. Follow these 5 key steps in exact order. Isolate heat input immediately. For solid fuel boilers, coal, biomass, RDF, rake out all burning fuel from the combustion chamber. For oil or gas-fired boilers, shut off the burner and fuel supply line. Reduce internal pressure, manually lift the safety valve to release steam and relieve boiler pressure. Open vent valves to aid depressurization and equalize internal pressure to atmospheric level. Diagnose the root cause. Check the water level in the sight glass and look for any anomalies in the water level sensors. Inspect whether the feed water pump is operational or burned out. Open the air vent valve on the pump and thoroughly inspect the piping system to identify the root cause of water loss, such as clogged lines, leaks, or faulty valves. Wait for the boiler to cool completely before entering. Once pressure has dropped to zero, enter the boiler and check all pressure-bearing parts to see if there is any steam leakage or visible water seepage. Inspect the steam-generating tubes carefully for signs of cracks, deformation, or other damage caused by overheating. After ensuring that the boiler is fully depressurized, you may use the induced draft or ID fan to accelerate cooling. However, never use cold water spray or directly introduce water into the boiler to cool it down. This is strictly prohibited, as it may cause thermal shock or tube explosion. Is it safe to use the ID fan while the furnace is still hot? Yes, because the incoming cool air from the fan helps reduce furnace temperature and lowers the heat on the exchange surfaces, thereby preventing further damage to the steam-generating tubes. At the same time, any remaining water inside the boiler will also cool down and cease generating steam. In the case of oil-fired or gas-fired boilers that do not have an ID fan, you can fully open all inspection and access doors to allow natural cooling, then proceed with the internal inspection. It is absolutely essential to identify and completely resolve all causes of the water loss before attempting to refill the boiler. If you skip this step and rush to refill water without a full assessment, it may cause additional damage or even trigger a boiler failure. Never resume water supply or boiler operation unless the underlying issue that caused the second-level low water alarm has been properly addressed and corrected. Refill the boiler only after issue is resolved. Switch to manual mode and feed water gradually while monitoring the side glass closely. Management approval is required before proceeding. Controlled restart. According to SOP, ensure water level is within safe operating range before reigniting the boiler. Follow your plant's official startup procedure or refer to our video 3 steps to safely start a boiler. Summary. Emergency dryout response. Workflow. Shut down boiler. Isolate fuel and heat source. Vent steam to reduce internal pressure. Cool the boiler and inspect thoroughly. Refill manually, only after fault resolution. Restart with full adherence to SOP. Do not skip steps. Many accidents occur when operators panic, immediately switch to manual mode, and pump water into a hot, dry boiler. This is a primary cause of boiler explosions. Part 4. How to prevent boiler dryout incidents. Don't wait for an emergency to happen. Prevention is always better than cure. Focus on these 4 essential practices. Daily water level system check per shift. Inspect the water level sight glass, sensor calibration, and alarm functions. Refer to our previous Divey video for a detailed guide on this procedure. Regular feed water system maintenance, clean filters, strainers, valves, and descaling treatment for pumps and economizers, ideally weekly. Log boiler water levels daily. Maintain operation logs to identify irregular patterns early. Operator training and refresher sessions. Train all boiler attendants in emergency shutdown, troubleshooting, and SOP adherence. Have you implemented these preventive measures yet? If not, start today to protect your boiler, your team, and your plant. Thank you for watching. If you found this video helpful, please like, share, and subscribe to Divey for more expert knowledge on boiler safety and efficiency. Wishing you safe and efficient operations.